Well, hello,
Hello.
Milks and Monaco,
Yep. Tag team.
back in action.
Back again. What's the lyric? But we'll look it up and get you know it.
All right.
But we're going to hit up the last two homework videos today.
Yeah, balancing equations.
Number 10.
Ooh, this is a big one.
Yeah.
This is kind of the
I
rite
just-
of passage.
I just did all the practice today in the pack, and I could totally make more practice, but, I'd be doing too much. So.
Yeah, I'm going to throw it out there. If anybody's still struggling after doing that practice and you want more, please come ask and we'll get you some more. Until you can't get it wrong, please.
I've got in the packet, I've got a simulation and games to play until you get it. So
Yeah.
really want you to understand this part of the unit.
Yeah. So first of all, why can we do it?
Why would I? Well, because they have to balance, right?
Well, they have to be accounted for.
Well, okay, this relates back to the law of conservation of mass. And
There it is.
my class did a little mini lab on this. I'll pass the chems on to you. Maybe you guys can do it. You can't create or destroy atoms. You can only rearrange them. And especially if it's a sealed system, which is kind of how we're imagining these reactions occurring, nothing can go missing.
Yep, it's all still there.
So we have to balance a reaction to show where it came from and where it goes to.
Right. So that's it. Can't be created or destroyed.
Nope.
Just rearranged.
There's another version of what we just said. All atoms have to be
Yeah.
accounted for in a chemical equation.
And the cool part is that next piece. Now it becomes very predictable.
Right.
So I can actually predict how much product if I know how much reactant.
Right.
That's where this game gets fun.
To simplify it, basically, if I know that I'm starting out with 20 grams of reactants, whatever my products are going to be after the reaction occurs, a gas, a precipitate, whatever, I know that all said and told, there must be 20 grams of them too.
Yes, totally.
Total. Nothing escaped, nothing enjoined. You have to have the same mass before and after the chemical reaction.
Right. We just don't compare grams to grams. We got to go through the moles, but we'll get there.
We're going to use moles and stoichiometry to get down to the atoms.
Right. So here's our first unbalanced equation. You want me to show you what that means by unbalanced?
Yeah, for sure.
Check it.
So what Mr. Milks is doing is picking up the pen right now, and he's setting up the work so that we can balance the equation. Yep. So that skill that we have, that is counting atoms, comes into play again.
That's what I just did.
Surprise, surprise. He counted the atoms.
On the left side and on the right side.
So on the reactant side, he sees that he has 2 moles of hydrogen atoms and 2 moles of oxygen atoms. And on the right side, he sees that he has 2 moles of hydrogen atoms and only 1 mole of oxygen.
So now we got to figure out how do we fix that, and that's this piece.
Because an oxygen went missing somewhere.
Right, I mean, that's not allowed. So, first rule, the only thing you can change is those whole number coefficients.
Mhm.
It is breaking the rules if you try to change subscripts, because now the reaction
Yeah, you're
itself
changing
changes.
the reactants of the products, and that's
Not allowed. Then when we're all said and done, the piece that we sometimes forget, we got to be in lowest common terms. So if we can divide, if all the numbers or all my coefficients are even, divide them all by 2, that kind of thing.
You'll see if you run into it what we mean.
Right.
And if you technically balance the equation properly and you have the wrong whole number coefficients, you might get some points on the regions, but we want to see it in the lowest terms possible.
Absolutely. So why don't you go through these real quick?
So there is 4 or 5 steps here, real simple. We got to first list all the elements involved, like you saw Mr. Milks do on the board. We're going to count each element on each side of the reaction to see if the number of moles of each element match up.
Did that.
We're going to change the mole coefficient in the chemical equation. So we're going to change the number of hydrogen molecules or the number of oxygen molecules or the number of water molecules to try and balance if it's out of whack.
Now, this is what we're talking about. It's in the actual equation. We got to change it there first before we recount.
And then we recount until all the elements are balanced. I put it this way. You count, compare, change a coefficient, repeat. Count, compare, coefficient, repeat. Count, compare, coefficient, repeat. You'll see.
Yes, let's do it.
Do it.
So, first one.
When you have a polyatomic ion in case, so polyatomic ions, remember they're on reference table E, and typically they're protected by the parentheses, or sometimes they're by themselves.
I'm feeling a quiz coming out on table E sometime soon. I'm just saying, my kids, I think, need it.
Yeah.
How can I recognize a polyatomic? We got to get better at that.
Well, anyways, a polyatomic ion is polyatomic ion. It's an important chunk of atoms that stay together. And when a chunk of atoms stays together in the reactants versus the products, we can just treat it as a unit and don't have to actually break it down.
So much easier. Okay.
Let's balance a synthesis reaction.
Okay, ready?
Mr. Milks is going to first list the elements that are involved. He sees he's got calcium and oxygen.
And notice I'm going to do that right underneath the arrow so I can do left side, right side better.
And he's going to tally the number of calcium atoms on the left to the left and the number of calciums on the right to the right. And now we see, we've counted and we're comparing right now. The calciums match. That's good. The oxygens do not. So what he's going to do is he's going to put in a coefficient somewhere where that's going to change the number of oxygens on the product side. So if he puts a coefficient in front of CaO, it means he's doubling the number of calciums and oxygens. So he put in a coefficient, he counts again, now we repeat, we compare. Does calcium match? No, but oxygen does. So now we go back to the other side of the equation. What coefficient can I put in front of calcium to make it match up? It's 2. Double the calcium atoms, and you've got it matched up. The last thing I would do, Mr. Mills, is I would put a 1 in front of the oxygen. Because just like in mathematics, if there's no number in front of X, we assume there's a 1. If there's no number in front of a molecule, we assume it's 1 mole.
Yeah. Remind me in class why that's so important, and I'll go through it. But to save time for now, we will move on.
Oh, delete. Decomposition reaction. So instead of seeing 2 things come together, we're going to see 1 thing break apart. And Mr. Milks can pick up a pen.
Okay.
He's going to list the elements involved and then count them, both the reactants and product side. Now we see right away that we do not match up. So he has to decide, how am I going to get phosphorus or oxygen to match up?
Yeah. And I see my instinct doing this a lot right off the bat is, see how this one's odd?
Mm-hmm.
I'm never going to get this number to be odd. I got to get this one to be even.
So
right off the bat,
he's actually going to double the number of P2O5s because
4.
There we go. We got 4 and
10. Now I can do that on this side. I can make P4 easy by putting a 4 there.
And he can make O10 real easy by putting a 5 over there.
Because now it's
5
10.
times 2, 10.
Oh, dang.
So we got a balanced equation.
And no putting in any 1s, I'm good.
There's no 1s needed. We done. Balancing equations might seem really quick and fast because we're chemists. We really know what's up.
Right. We also want to keep the videos kind of short for you.
Here we got some
Feel free to
polyatomic
rearrange.
ions. So what he's going to do is he's going to list his elements as elements. And polyatomic ions are going to stay as polyatomic ions because it doesn't really get broken up in this reaction. That particular portion of the reactants and products doesn't get rearranged. It stays together. So as he counts here, he sees that there's 2 NO3 nitrates on the product side.
Okay,
And he needs to get 2 NO3s on the reactant side. How would you do that?
Well, so first things first, I didn't tell you guys this specifically. I want to make sure we do this. I'm not going to change the numbers down here first. I got to change the numbers up here first. This is big.
Yeah.
This is a big common mistake. Kids try to skip ahead. Now we're in trouble because once I change this number, now I got to change 2 things. I got to change the silver and the nitrate, which I was trying to change anyways. But so
And
now
in-
that's good.
In getting
This is
nitrate
good.
balanced, he puts silver out of whack, which then he goes to the other side of the arrow, product side, and fixes it. Really, really easy. He writes in the 1s to show that there's really 1 mole of these other compounds involved, and we're done.
It's good.
It's kind of like a game of ping pong.
It really is.
Back and forth, back
And
and
then-
forth.
and then
What do I
right
got to
here is-
do
right
to make
here's
it
the
all
net.
match up? That's the net. The arrow is the net. Yeah,
Right.
sure. Let's do a double prism reaction with a polyatomic
One
ion.
last one.
Last one. Wow, lots of polyatomic ions, but guess what? Don't let it scare you because they stay together as a unit. We can keep them as a unit when we balance. So sodium, nitrate, calcium, and sulfate. Let's count them up. He's got a sodium, a nitrate, a calcium, and a sulfate. He's got 2 sodiums, 2 nitrates, 1 calcium, and 1 sulfate. Ooh, what you gonna do, Mr. Milks?
Well, I got to get Na times 2, so I'm going to put a 2 here.
Distribute
And
it through.
reevaluate,
Okay,
I got
so
2 NAs. I got 2 nitrates, and oh look, check. So that real big, scary looking one, super easy,
not so bad.
super easy.
And remember, when he's putting a coefficient in, he's doubling the amount of moles of that particular reactant or product.
And of the whole thing.
And the whole thing. And that's why he's distributing and recounting to see if we've balanced out.
That's it.
We did. So 2 pages in our practice pack.
Yes.
Definitely plenty of room to do it all. I did it today.
Yeah, I did. it
Very
too, yeah.
straightforward. Don't be scared of the ones that look scary.
Right.
Wink, wink, nudge, nudge,
Yes.
nod, nod.
Right. And please follow exactly how we did it. I think we were very consistent with how we did it. this is the way that it works the best every time.
And if this isn't working for you, there's some simulations in the packet that can
Yeah, have fun
definitely
with
get it going. Okay, a lot more visual for some of us who are more visual learners.
There you go.
Thanks.
See you.
Bye.